Okay, so let's talk about why these two statements have to equal. Let's first recall that if you have nth root of x, okay, this is the same thing as saying x is equal to y to the power of n. Okay, so let's take the right side. Okay, this is the definition of the roots. Okay, all roots. So if you have n a to the power of m, let's set that equal to let's set it equal to x. Then we can clearly say what's inside the root is equal to x to the power of n. Okay, so here we can use the exponent law and raise both sides by power of 1 over n. Pick a different color here. So 1 over n, 1 over n. Okay. Then what we have here is a to the power of, we can use the exponent line, multiply these two, m over n is equal to x. Of course, we come full circle, x was equal to this. So that's the proof. Okay, that's the proof that why these two statements have to equal to each other. Now the important thing is, once we understand that these two are equal to each other, anything that looks like this, we can first convert it into this form and use exponent laws to simplify. Okay, so for example, let's say you have x to the power of cubed square root times by third root of x squared y z cubed. Okay, so let's simplify this. How do we do that? Well, first, convert into exponent form, like this. Okay, then we get x to the power of 3 over 2. Okay, distribution, x to the power of 2 over 3, y to the power of 1 over 3, and z to the power of 3 over 3. Common base of x, so we can add this two together. So you're gonna get a common base of 6. You get 9 plus 4. Y is by itself, and z, okay, z becomes power of 1. So we get x to the power of 13 over 6. It doesn't reduce. Y to the power of 1 over 3, and just z. We can always convert it back into the root form. Okay, but when I do that though, note that this is bigger than 1. So we can actually separate that to x to the power of, subtract 6 from there. Actually, we can subtract 2, right? 12, and get 1 over 6, y 1 over 3, z. Right, so the reason why I did that is because these two don't have to belong inside the root. This is going to be the 6th root of x, and this is going to be the 3rd root of y if we convert these two back into the root form. So sometimes the question will ask you to turn it back. Sometimes the question will just ask you to leave it the way it is. If you are allowed to leave it in the exponent form, we can stop right here.